All right, so today we are starting chapter 11. We're going to start with simplifying square roots. So before we do that, we're going to review how to find the prime factorization of a number. Do you guys remember?
Yes.
You use a factor tree. Good. So the way I did it when I was making this was I just divided it by 2. Dividing by 2 is really easy anytime you have an even number. So if you have a calculator, great. If you don't, you got to do some long division off to the side. But 450 can be broken down into 2 and 225.
Can you break it down to 5 and 45?
Then you can keep breaking it down. The 2 is prime. That one is 5 and 45. The 5 is prime.
That one is 5 and 9.
5 and 9. 5 is prime. 3 and 3. What are your questions on prime factorization?
Do we have in the end write 2 on?
Yes, so that's how we actually write it. The factor tree is how you find it, but your answer is all the prime numbers multiplied out. So I have 1, 2. I have 2 3s, so 3 squared. And then 2 5, so 5 squared. And the way you could check to see if this is right is type it in your calculator and see if you end up at 450. And you would. So yes, to start off 80, you could start off with 80, but to start off 800, I did 2 and 400. 2 is prime. 400 can go to 2 and 200. 2 is prime again. You can just keep going by 2s. 2 is prime again. 2 and 50. 2 is prime again. 2 and 25. 2 is prime again. 25 is not divisible by 2, so you got to change your approach a little. 5 and 5. Good. So we have 1, 2, 3, 4, 5 2s. So 2 to the 5th and 5 squared. What are your questions? Okay, so we use this idea on the warm-up, right? An inverse is an operation that undoes another operation. So addition and subtraction are inverses because they undo one another. Multiplication and division are also inverses because they undo one another. We use inverses, just like on the warm-up, when we solve equations. So if you want to undo something, you do the inverse operation. Again, this is a review. Any questions?
Do you have any tissue?
I don't. You can run to the restroom. All right. So the inverse, remember, is an operation that undoes another operation. The inverse of squaring a number is taking the square root. So you guys all know how to square a number, right?
Yeah.
You just take it and multiply it by itself. Yeah. The square root is what number times itself gives you the number in the square root. It's the inverse of squaring something. So here it is written out a little more formally. This is how you'd see it in a textbook. If a squared equals b, then a is the square root of b. So if I had said, what's the square root of b? You'd think, well, what number times itself gave me that in the first place? And in this case, it would be a. Okay, here it is with real numbers. If 8 squared is 64, and I asked you the square root of 64, you'd tell me 8. So it's just the reverse of squaring something. Questions? Yes.
Now, if we said the square root of 64 was 8 squared,
It's not 8 squared, it's just 8.
would we get
You would get it wrong. Yes. Yes. All right, this is what a square root looks like. We call it a radical, and the number inside the radical is called the radicand. So the symbol is the radical, the number on the inside is the radicand. Kind of cool words, right? So this is how I'd write the square root of 64. This means what is the principal or non-negative root. So the square root Technically, negative 8 times negative 8 also gives me 64. But usually we just go with the positives. That's why it says this, the non-negative root or the principal root. So again, you'd say 8. All right. Without a calculator, the square root of 49. 7. Good. How did you know that so quickly? Some people haven't even written it down yet. They don't even know where we are. Because 7 times 7 gives me 49. So the square root of 49 is 7. What are your questions? So when you think of 49, you could do a factor tree, right? Some people looked at it and they just knew it was 7. Radicals, when they're called perfect squares, those easy ones, you might not want to do a factor tree. You might just look at it and say, hey, it's 7. That's fine. I don't need to see a tree on this one. If you're drawing a blank, though, start making a tree. And you can see 7 times 7 is how we got the 49. And my answer is just 7. If everything is a repeater, meaning 7 times 7 gave you the 49, you no longer put the square root. The biggest mistake I see with square roots is people don't know when to not write the square root. If 7 times 7 is 49, you found the square root of 49. You don't put it in a square root. It's just regular 7. Any questions? Okay. Try not to yell it out.
11.
What is it?
11.
It's 11. Yes. So this is asking you what number times itself gives you 121. If you did a tree, it would look like this. They're both repeaters. So the answer is just 11, not square root 11. Don't put it in a radical.
You can put it in a radical, right?
Don't put it in a radical. It would be wrong if you put it in a radical.
What if we make this like 11?
Okay, so do you see how this has a symbol in front of the square root?
Yeah. So we got
You put that same symbol in front of your answer.
Okay. Which is 9.
So plus or minus square root 81. The square root of 81 is 9. So our answer
Positive or negative 9.
is plus or minus 9. What are your questions? Now I want the negative square root of 16. Negative 4. You just keep the symbol in front of the square root.
Oh, okay.
All right. Square root of 1,764. All right. If you don't know by looking at it, we got to go the other way, the other approach to do a factor tree. It ends in a 4, so I know it's even. Divided by 2. Now, 882 is a little more manageable. Still even. So I'm going to divide by 2. Notice I'm circling the prime numbers. That's kind of how I know, like, hey, this number's done. This number's done. All right. 441. So it ends in a 1. So 2 is no longer eligible. Do you guys remember the divisibility rule for 3? If you add the digits together and that number is divisible by 3, the number is divisible by 3. So 4 plus 4 plus 1 is 9. That's kind of the shortcut way. Or you could just type in 441 divided by 3. And if your calculator gives you a whole number, it's divisible by 3. Okay, so is 147 divisible by 3? Yeah, when you add 1 and 4 and 7, you get 12. And 12 is divisible by 3. So that is divisible. Yeah, 7 goes into 147. Yep. And then 49 is 7 and 7. Okay. Now, we are looking for repeaters. The 2 and the 2 repeat.
The 3 and the 3 repeat.
The 3 and the 3 repeat. The 7 and the 7 repeat. Now, when a number repeats, you bring it out of the radical, but you only have it once. So we're going to have 1, 2. We're going to have 1, 3. And we're going to have 1, 7. What's 2 times 3 times 7? 42. Good. I always think of the radical like, okay, so like the 1,764, it's stuck inside, you know? You don't go play outside by yourself. That's weird. No, you got to get your friend, right?
No.
And all you need is one good friend to go play outside.
I'll be playing with myself.
All right. Well, I like to play outside with friends. So, you got to find a friend, okay? The 2s found each other, they get to come outside. The 3s found each other, they get to come outside. The 7s found each other, they get to come outside. Sometimes you'll have leftover numbers that don't have a friend. They have to stay inside. Okay?
Why can't everybody be friends?
I know. It's so sad. There's even like bullying in the world of numbers. It's tragic. All right. Another big one. Our answer is going to end up being negative because I see a negative out front. So 5,184. What am I going to do? Make a tree. It is divisible by 2. And it's divisible by 2 again. And it's divisible by 2 again. Now remember, you get to use calculators, so if you're like, how does she know what all this is? Just hit divide 2. Divide 2. Divide 2. You don't even have to retype it. Just divide 2. Divide 2. Divide 2. Okay, divide by 2.
So there's 2 times.
Divide by 2.
And then another.
Divide by 2.
Oh my lord.
And then another time. Wait.
I'm sorry. Okay, I'll slow down. Especially now because it's not divisible by 2.
9.
But it's divisible by 3.
9.
Or 9 and 9, either way. And then each 9 is 3 and 3. All right. We need some friends.
Everything.
Friends. So yes, everybody's coming out to play. We have 2 times 2 times 2 times 3 times 3. 5 groups of friends. So that's 8 times 9?
Yeah.
72. And then tack that negative because, look back at the original. The only thing this means is that you have a negative in front of your answer. Now, a few of you are talking. Do you guys have questions? All right, so when we take the square root of a fraction, we're actually taking the square root of each piece of the fraction. So we're taking the square root of the denominator, the square root of the numerator. Does anyone know what the square root of 1 is? 1. Does anyone know what the square root of 9 is? 3. If you want to make a tree for those, do it. I would not make a tree for 1 or 9. Any questions?
Wow.
All right, same idea. We have a a fraction inside a radical, and I have a plus or minus symbol out front. So I know my answer is going to be plus or minus. We're going to take the square root of 81 on top, square root of 25 on the bottom, and it's a plus or minus. Oh, no, no, no. Woo! Okay, this is a common mistake, and this is exactly what I was talking about a minute ago. People say, oh, well, the square root of 81 equals the square root of 9, which equals 3. What's the problem here? Oh, I'm just focusing on the numerator.
Oh.
You have the square root twice.
You have the square root twice. If 9 times 9 gave you 81, then that middle step is just regular 9, and there's nothing else left to do. So don't keep taking the square root, taking the square root, taking the square root. Once you found what number times itself gave you that number, that radicand, the square root is gone. You don't have to find out what gave you the 9.
Are you laughing?
Okay? It's a common mistake. I see it all the time. $55.
Dang.
That's 1.44. All right, so I'm going to rewrite that as a fraction. So do you guys remember how to do that? It is out in the hundredths place. So we make it a fraction over 100. The memory trick I like to use is however many numbers are after the decimal, that's how many zeros you need. Okay? And then I can take the square root of the top and the square root of the bottom. So the square root of my numerator is just going to be 12. The square root of my denominator is going to be 10. These numbers are getting a little larger, so you might need to do the trees. A lot of people, it seems like up to 12 you kind of just know, right? Like 12 squared is 144. Did you guys know that?
Yeah.
Okay, so that's one a lot of people can do in their head. 10 and 10 makes 100. A lot of people, I mean, that's a pretty simple one. But if you want to do the trees off to the side, go for it. I just don't feel like it's really necessary, like 1 to 12 especially.
Can you make that 6 over 5?
Yes, and then of course we reduce. They're both even, so divide them both by 2, and we end up with 6 over 5. All right. Example 5. All right, same approach. Let's rewrite this as a fraction. So I need how many zeros in my denominator? 4. There's 4 numbers after the decimal. So I need a 1 and 4 zeros to write it as a fraction. Now what can I do? Well, first we need to take the square root of the numerator over the square root of the denominator. You take the square root of each piece. Okay, 225. Just, it's 15.
Wait, what?
15 times 15 is 225. If you didn't know that, A, now you know that. You'll see it again. B, use the factor tree. Start dividing by 5. You'll end up, the prime factorization will be 3 squared times 5 squared. And then the 2 3s come out. 2 5s come out. 3 times 5 is 15. So you can do a tree on that one. And then anytime you're working with the zeros, like half the zeros and half the zeros, you know what I mean? So it's going to be 100 times 100.
Do we simplify?
Yes, of course. Those are both divisible by 5. So it's going to be 3 over 20. And again, we started with the plus or minus. You can see each step of the way, it just hangs out in the front, and it ends up in our answer too. Okay. Anyone having any thoughts?
Tweet. Tweet.
I don't think so.
No. Can you simplify? No. You can simplify it.
Yeah, do you see how those are both even numbers?
Oh, yeah.
Let's simplify them. What's 18 over 32?
Yeah.
You could do it by
Is this it? Wait, 6.
9
yeah.
over 16, and I feel a lot better about 9 and 16. Why? Those are both perfect squares. So I can take the square root of 9 and I get 3. I can take the square root of 16 and I get 4. And I feel great about my current situation.
That is so awesome.
It is awesome.
Finally right for one.
Ooh, I don't know if it's going to work here. They're not even. Yes! 3 goes into both of them. How many times does 3 go into 12? Ooh, that's a perfect square. How many times does 3 go into 75? 25! That's another perfect square. What's my answer?
2 over 5. Negative.
Negative 2 over 5. Good. Aren't these fun?
No.
Oh my goodness. I could do these all day.
Well, then can you do my homework?
No.
I don't think that's how that works. I mean, I'm trying to.
Oh no.
Wait,
Oh, no.
I don't like that.
Oh no. Who's freaking out?
Wait, you do parentheses first, so you square it first.
What?
Square root
What?
and then square.
Square root first.
Square root and then square.
Do we know the square root of 63?
What's the square root? No? Yeah, no. Is it 8? Put up. 8.
Times 8 is 64.
That's 60. Oh no, that's 63. Okay, this is not funny. I was thinking 3 4.
What do you mean distribute the exponent?
I'm not talking to you.
No, we have that. Wouldn't do it.
Okay, hold on. She's on to something. Okay, so she said times 63 by 63.
So I'd have 2.
So you're telling me I'll have 2 63s under a square root.
What?
Well, how many 63s do I need to get rid of the square root?
2.
2.
Whoa.
And she just told me that I have to.
Hold on. How in the world?
It's 63.
It's 63! What is squaring something and taking the square root?
It's
They're inverse operations. They undo each other.
So the answer is 63.
The answer is 63. Woo! Isn't that fun? Love it. Any questions? Everybody okay back there?
Javis, you get it?
Okay.
No, not the same thing.
Can we not?
Well, you gotta square it.
Not do the square root?
You gotta square it and then undo it.
It's 40.
Check the D40.
Not 41.
It's still 41, correct?
They go away.
Is it just 0? It's 41.
Yeah, same thing. If the squared is inside the radical, if it's outside the radical, they're still undoing each other. It's like saying, well, plus 3 minus 3, they undo each other. Well, minus 3 plus 3 still undoes it. You know, it doesn't really matter. The order of the inverse doesn't matter. They still undo one another. Questions?
No, because you know sometimes.
Ooh.
It's 10 minus 6. Which is
They're squared.
4. Oh, squared. 4 squared. 4 squared. 2.
Okay, so do you guys remember?
It's 2. The answer's 2.
Do we subtract first and then we...
Yeah, so this one, it doesn't really work the way that the previous ones work. That only works like over the operation of multiplication. So in this one, we actually need to square it, then subtract, then take the square root. The problem is the minus sign. You can't take a square root over a negative, like a minus sign. By the way, you also can't take the square root of a negative number unless we're talking about imaginary solutions, which we're not going to get into. All right, yes. Come see me as a junior and we will get all in there. All right, what is 100 minus 36? 64. And the square root of 64 is 8. So, just like this kind of goes back to, you can see my other class is working on it, an example on the board. It comes back to the same idea as like x minus 3. If I squared it, you can't just square both of them. Same thing here. You can't just take the square root of both of them when you have a subtraction or an addition sign. Make sense? Okay.
10 minus 6.
Okay. Yes. Shh. You gotta let everyone process it. You are correct though. So we have a square root squared minus a square root squared. See how the minus sign now isn't really affected? It's not under the radical and it's not being squared. It's not within the parentheses that are being squared. So you can use the inverse operations of squaring square root. So you'd have regular 10 minus regular 6, which is 4. Do you guys see the difference between this one and the last one?
Yes, ma'am. The section.
Okay, what do we learn about today?
What are these called? Square roots.
Yeah, I'm actually just going to write this. All right, here comes your homework.